The James Webb Space Telescope, the premier observatory of the next decade. An international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It will study every phase in the history of our universe, ranging from the first luminous glows, after the Big Bang, to the formation of solar systems, capable of supporting life on planets like Earth, to the evolution of our own solar system. The James Webb Space Telescope will be launched on an Ariane 5 rocket, and is scheduled to be launched in this year. Webb will be launched from Arianespace's ELA-3 launch complex at European Spaceport, located near Kourou, French Guiana. For the telescope to fit into the rocket, it must fold up. And after launch, the telescope will deploy on its 30-day, million-mile journey out to the second Lagrange point L2. The James Webb Space Telescope will be a giant leap forward in our quest to understand the universe and our origins. Webb will examine every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of galaxies, stars, and planets to the evolution of our own solar system. Webb will be a powerful time machine with infrared vision that will peer back over 13.5 billion years to see the first stars and galaxies forming out of the darkness of the early universe. Webb's unprecedented infrared sensitivity will help astronomers to compare the faintest, earliest galaxies to today's grand spirals and ellipticals, helping us to understand how galaxies assemble over billions of years. Webb will be able to see right through and into massive clouds of dust that are opaque to visible light. Observatories like Hubble, where stars and planetary systems are being born. Webb will tell us more about the atmospheres of extrasolar planets, and perhaps even find the building blocks of life elsewhere in the universe. In addition to other planetary systems, Webb will also study objects within our own solar system. The observatory is the space-based portion of the James Webb Space Telescope system, and is comprised of three elements: the Integrated Science Instrument Module, ISIM. The Optical Telescope Element, OTE, includes the mirrors and backplane. The Spacecraft Element, Spacecraft Bus and Sunshield. The Integrated Instrument Module, ISIM, includes the following science instruments: Mid-Infrared Instrument, MIRI. Near-Infrared Spectrograph, NIR, Spec. Near-Infrared Camera, NIR, Cam. Fine Guidance Sensor, Near-Infrared Imager and Slitless Spectrograph, FGS, NIRISS. To make observations in the infrared spectrum, the JWST must be kept under -223.2 degrees Celsius, or -369.7 degrees Fahrenheit, otherwise, infrared radiation from the telescope itself would overwhelm its instruments. It therefore uses a large sun shield to block light and heat from the sun, Earth, and Moon. The shielding maintains a stable temperature for the structures on the dark side, which is critical to maintaining precise alignment of the primary mirror segments. This was all about JWST. I'm hoping that launch of this telescope will happen this year, so that we can get new information about our universe as soon as possible.